Okay, so this is Modernize Mainframe Operations with Red Hat AAP, presented by Fabio, known as Fali. And this is session 9N for when you're giving your feedback. Over to you, Fali.
Thank you. So today we'll be talking about how to modernize operations with AAP. And let's start from the very basic. Who am I? I've worked in IT since 2004, mostly in consulting roles as well as operation kind of roles. And I've been using Ansible since 2013, which basically means more than 10 years today. And I've written a few books on it and do work for Red Hat as an Ansible specialist. So I would like to start with a little bit of a situation I found a few years back. It was one of at the very beginning of my Ansible journey, and the situation was that there was a complex architecture, and the complexity was increasing constantly, as it usually does in all IT and I would say all systems. And what happened was that a couple of operation people left. So they were overworked, they were stressed, they left the company and went in other places. So issues started to become obvious because that complexity was somehow managed by all those operation people that were working on the stuff there. But as soon as they started to move out and leave the company, then it started to become more and more obvious that something was not really there. So the solution, as every time happens with management, is to create a project. They call it Project Diamond. They would have solved all issues, at least in the IT department. So the goals were very simple. The first one was to reduce complexity. So we discussed the fact that they had an increased amount of complexity. The goal was to reduce complexity. Make every process explicit, which means that at the time there were some processes that were like some store procedures or some other kind of not very transparent processes or steps of processes, which made everything more complex, or at least that was the assumption. So make every process explicit seemed at least a good idea. And then avoid the dependence of process to certain people, because the issue was that since a lot of those processes were not really documented, you really needed that specific person that really knew that process to be able to actually do it properly. So everything starts, the project starts, a few months pass by, and there seems to be a little bit of an issue. What should have become Project Diamond, people started to call it as Project Coal because it seemed like all the components were there, but it was a huge mess. Now, the complexity actually increased. Instead of decreasing, it increased. So, probably not exactly what they were expecting or hoping for. Every single process was kind of explicit, but still not really explicit because it was usually documented somewhere, but a lot of times it was referencing other parts of things that were not really documented anywhere, or maybe they were documented but in other languages or situations. It was a little bit of, it was better surely than before, but still it was not achieving the goal. And they actually avoided successfully the dependence of running a process to certain people because by documenting those processes and creating some scripts and other kind of automation, actually they were able to do this. Though they still had a huge problem in changing the processes, which was still a very activity that was possible only for very few people. So what went wrong here? What went wrong was that their approach to automation was basically going to any head of team in the IT department and basically telling them, look, you have to document your processes, you have to automate your processes, you have to make sure that your processes do not depend on specific people and so on and so forth. But they were not really clear on how to do this. They left that freedom to every single person, every single team within the organization. And the issue over time that became apparent was that every single team interpreted those ideas in different ways and implemented this automation in different ways. So in the end, there was not that big automation that was solving all companies' issue, but there were pockets of automation in the various teams. So that situation let me understand or better identify probably something that was probably very obvious, or at least it is today to me, but it was not at the time. So we have seen in the history of humanity a lot of times automation or development of new techniques that were easier or quicker than what came before. So in the end, I would say that automation happens when one person meets a problem that they never want to solve again. So automation is a very common thing in our world. The problem, though, is that if you are an enterprise, you do not need pockets of automations. You need a enterprise scale, coordinated scale automation. So if you look at from this perspective, you can notice that you have multiple teams or departments, silos, whatever are in your company, of people in your IT, that everyone is focused on something. So, for instance, you have network ops that are focused also on network operations or deployment potentially, security operations that are focused on security, developers, DevOps, kind of things that are developer and are specialized on developing and managing application, and then the more classic IT ops or system ops that are more focused on the operating system. But the risk is that you have those verticals, basically those silos, going in a more isolated way, creating their own automation. And if you actually map out what exactly are the domains for those people, you will notice that there are some domains surely different for every one of those. So, for instance, NetOps will be focused on networking, and IT ops will be focused on compute. But then the lines start to become a little bit less obvious. So, for instance, when we are starting to talk about clouds or hyperconverged infrastructure, as they were called a while ago, then all those distinctions kind of can go away. And even more, if you then start to focus on things that are really value for the business, so the application lifecycle, for instance, the compliance, or all the aspects about security are absolutely cross all those verticals. So what you really need is to break down that silos and have that single language, single way of automating or creating documentation or whatever else in your estate. Now, having considered this, I also want to introduce another concept that I think is critical before we go anywhere along this, and it's the concept of idempotence. Now, the name is weird and very academic, I would say. And the definition is also fairly academic because it is the property of certain operation in mathematical computer science, obviously in our case it's going to be computer science, that can be applied multiple times without changing the results beyond the initial applications, which basically means that there are some operations that you can do multiple times and will change the result only the first time, while others will change result every time. Let me give you a couple of examples. So an operation that is not idempotent is multiplied by 2. So if we start by 1, we multiply it by 2, and then it becomes 2. If we multiply 2 by 2, it becomes 4, and then 8, and then 16, and so forth. On the other hand, there are other kind of operation which, for instance, elevate to the power of 0 is one of those, where no matter which number you start from, you elevate to the power of 0. In this case, it will make 1, and then from that moment onward, it will always be 1. So in the end, it's like there are those two very big categories of operations. And the concept of idempotence is very, very important in computer science and automation more specifically, because if we have an idempotent system to automate, that means that no matter if it fails or when it fails, or if we are not sure if it failed or not, or if we are not sure if the state that we described is exactly what we want, we can just rerun the automation many, many times, and worst case scenario, nothing will happen. Or if something needs to change, then only those things will change to match exactly what we described. So effectively, the idea here is that we are going to describe the state that we really want more than the process to obtain that state. Now, that's not always possible, but as much as we can move to that approach of idempotency, the more easier it will be to have and manage automation. So here, Ansible comes into the picture, and Ansible is an automation system, and I think has a lot of interesting features. So let's start from what could be the very niche part of this. So which architectures are supported by Ansible? First of all, Ansible can run on automate all architectures. So effectively, if you have, for instance, an ARM server or an S390 server, they can be automated with Ansible. So all operations on those can be automated with Ansible. And more specifically, if we are talking about operating systems, I would say the huge majority of operating systems are automatable with Ansible. But also, there is the controller part of Ansible, which is Ansible Automation Platform, which is the Red Hat version of this. There is also AWX, which is the open source version of it, that actually are able to run on ARM Power, S390, and x86. So this means that from all of those architecture, those 4 architectures, you can really automate every architecture that is out there. And also, the operating system that you will need to have to run AAP, or RHEL, or OCP, you can run it on OpenShift or Red Hat Enterprise Linux. Now, on S390, more specifically, since we are talking about mainframe and S390s, it can be run on IBM Z RHEL on IBM Z or Linux One, and within IBM within OpenShift in IBM Z or Linux One, and in IBM ZCX Foundation for Z, as well as in the Container Extension Foundation for OpenShift, and in ZOS ZCX. So talking about Ansible, it is open source, first of all. So everything we are going to discuss today is going to is open source, effectively. Now, Ansible itself is just the core part of this. There are a lot of software around Ansible. So AWX that I mentioned before is one of those, but they are still all open source. Simply, they are different tools for different tasks. Mainly Ansible works in push mode, so it's agentless. So what happens really is that you have that controller machine, AAP usually, that connects with SSH or other means to the various machines that needs to be automated, and then it will push the automation to that machine. It's based on infrastructure as data. So effectively, you're going to describe the infrastructure as data in YAML form. It's going to be a little bit like a process sometimes, more like a description other times. It's really flexible, but still it uses that YAML code. It's not like Python or Ruby or other languages. It's just YAML, plain YAML. Due to these reasons, it does have that very gentle learning curve that many people actually enjoy in learning and using Ansible. And as a consequence of this, also is very readable, which means that even people that usually are not very aware of how exactly the IT internals of some operations can still read that YAML code and understand what's going on. Also, it does have collections, which is like a packaging way of shipping software. And this help you to reuse the code, because if you have a certain kind of function, let's say, certain kind of service that you want to reuse in multiple parts of your organization, you can simply package this in a collection and then reuse that collection in multiple parts of your organization. But also, this helps to have a huge ecosystem, because in the same way that you can package that code in a collection and then distribute it internally in your organization, you can also distribute it externally if you want. And this means that many people actually do want to distribute their collection externally, and this creates ecosystem. But also within the Ansible ecosystem, there are a lot of other tools like AWX mentioned before that allow you to do much more with Ansible. Now, there are some key concepts in Ansible that are important to be remembered. The first one is host. Host is the target system that needs to be automated. The second is group. So effectively, this is like a group of hosts. And the reason for this distinction or this idea of grouping is obviously it makes sense to manage multiple hosts that are similar in a similar fashion. But also, Ansible will always focus on groups, not hosts, in the sense that when you do write the automation itself, you are going to write the automation to automate a group of hosts. Then maybe in that group of hosts, you only have one host. So effectively, you are automating that host. But this always place you in a situation where you think about, okay, but I might want to have an additional node in future, and how to manage that. So this helps you to eventually, when you need it, just add one additional node into the group, and then you will get the two machines configured by Ansible exactly in the same way. So this helps you to think about that pet versus kettle things that is often a conversation lately. All those hosts and groups are collected into inventories. Inventories have different formats. They can be INI files, they can be JSON, YAML, but in the end, it's like a structured list of hosts and groups. Also, we have the concept of module. Basically, a module is a piece of code that you don't really see, but you interact with. And it's used to do certain operation on certain system. So, for instance, a module would be DNF. DNF is the module, the Ansible module to manage the DNF program on Linux, which is the software to install and uninstall softwares. So with that module, you can automate those operations with Ansible. And to do so, you actually do a task. A task is basically an instance of a module with a bunch of parameters declared as that are going to be an input to that module, and eventually some variables to manage the outputs of that module, if that module gives any output, and if you really care about managing that output. If you have a lot of tasks, then you might want to have some roles. Roles are an arbitrary creation, like they are a file where you put a lot of tasks. And the idea of a role is that it allows you to create a higher level of abstraction in automation. So just to give you an example, a module, as said, can be DNF that installs software. Let's say HTTP, the Apache web server. And then there is another module that allows you to start a service or open a firewall port, all those kind of things. But a lot of times you will want to have all those operations done at the same time, or on any system where you install HTTP, you will probably want to start it, open a port, maybe apply some configuration changes that are standard in your organization and so on. So you can group all those kind of related automation into a role. And once you do that, you can then reuse roles in multiple ways. Now, roles should be idempotent in the sense that if they are not idempotent, you will find way more complexity in managing those. But obviously, Ansible does not force you to create idempotent roles. There are then playbooks. Playbooks are really the part that links inventories or groups of machines into the inventory to specific operations. So in playbooks, you can either have modules or roles, or potentially both as well. And what you do is at this point say to Ansible, I want on this group or groups of machines those roles and modules applied. And those can be idempotent or not. A lot of times you will have some non-idempotent playbooks. So for instance, an example could be to have a machine that restarts because you need to restart a machine for some reason. That's not an idempotent operation, and that's okay to have it in a playbook if it makes sense for you. It's probably less okay to have it in a role due to that inheritance that risk to become a little bit complex when you're importing a role in a playbook and you are expecting it to be idempotent, but it's not. There is then the concept of collection that we have already mentioned, and a collection is basically that package of roles, modules, and other kind of resources, as we will see, that can be then easily shifted around in the organization and outside the organization. And the last concept is execution environments. Execution environments are Linux containers containing some libraries, the Ansible executable, as well as some collections. Now, starting from the top, going to the inventory part, inventories can be of many different kinds. I've mentioned that they can be INI files, YAML files, JSON files. So those would be files that a human writes, but also they can be dynamic. So effectively, they can be, you can provide, instead of a file, an application, a software script, whatever you want to call it, that actually populate that file. So basically, a script that has that a JSON or YAML output that is structured in a way as if you were to be written in it. So there are obviously a lot of scripts already available, dynamic inventory is already available. The bigger clouds all provide one of those, but also you can have them from OpenStack or other kind of systems. But also you can bring your own. So if you have a CMDB, for instance, within your organization, you can actually write a script, could be Python, could be any other language, that pulls that data from your CMDB, and on the basis of that data, it then creates that inventory. So as you can imagine, it becomes very easy to start having a lot of information on your machines, because probably you already have those information somewhere in your organization. And since it's a script that you're writing, you can even query multiple sources of truth and then figure out a way to merge them so that effectively in that inventory can put information even from more sources than just one if you have multiple. Now, when you write a playbook, this is the kind of code you would be writing. So this is very simple playbook. This, as you can see, it says host all, which means all groups. Even though it's called host, is actually aiming to groups, not single host. Become true means that this playbook is going to be operated with privileged escalation of privileges, so effectively a privileged access, root or sudo if you are talking about Linux, or other kind of privilege escalation if you are talking about other operating systems. And then we have a couple of tasks. And as you can see here, there's task name. This is just the description of what the task is going to do. Ensure HTTPD is installed. Then we have yum, could have been DNF if you are on a distribution that uses DNF. And these are softwares to install under software. And in this case, we have name, which is the package name, HTTPD, state latest. So effectively, we want to have the latest version of HTTPD. And then the second one uses the services module, which allows you to handle services. So it would use systemd, for instance, on Linux systems, or could be other in its systems if the target operating system uses something different. And still, we are giving it a name, so ensure HTTPD is started. That's a clear description, I think, of what we are expecting that code to do. And then we provided a couple of variables. One is name, still HTTPD in this case, and then state started. So effectively, we're expecting that that service is in state started. Now, talking about collections, we mentioned the fact that they can contain playbook, roles, but also they can contain a lot more stuff. So an example would be modules. So additional features, let's say, of Ansible, as well as plugins. So the become that we have seen just before is actually implemented with plugins. So if you have an operating system or a situation where the way you do escalation is different, privilege escalation is different from the one that are already supported by Ansible, you can write your own plugin and then potentially distribute it via a collection. Also, it would be nice to distribute documentation and tests in the collections as well. And there are already a lot of collection around. So this is Galaxy. This is like a kind of a GitHub of Ansible collections, if you want to think it in this way. And there are a number of collections. In this case, those are all created and published by IBM, but also there are many more that are published by other vendors or people potentially, and those are for Z operations. So as you can see on the first one, for instance, that's IBM ZOS Core. As the name suggests, this is going to help you with roles, playbooks, modules, documentation, and so on about how to automate stuff with Ansible for the ZOS Core. And then all the others are, as the name suggests, other things other collection that can help you automate multiple other tasks. So collections are very nice because they allow you to distribute your code within your organization and outside, but also because you can use collections that have been written by others, like IBM vendor in this case, and simply download them and leverage code that has been written by them, has been validated by them, and then you just use it and benefit from not having to write all that code. Just to give you a couple of numbers to give you an idea on the size and the popularity of Ansible, those are not S390 specific, those are like global. Obviously, S390 is a part of those numbers, but it's not the whole totality of those. So there are roughly 2 million downloads of Ansible per month, and we are talking only about the version distributed by Red Hat. So Ansible can be found as open source project on GitHub or distributed by Red Hat, which is still open source but paid for. Also, we cannot really count the downloads for GitHub for due to how GitHub works, but we can count the one that are officially downloaded by us from our website, and this is 2 million. So the real number is way bigger. There are more than 2,000 customers just on the Red Hat side, and then there is a huge amount of non-Red Hat customers that are still Ansible users. There are more than 4 million systems that are managed by Ansible, just Red Hat versions, more than 4,000 modules, and the open source version, so github.com/Ansible/Ansible, is the seventh most used or contributed to project on GitHub. Now, the way we think about automation, it's in 3 different steps, because we think that it's important to focus on all areas of automation. So the first one is the creation. So when you create Ansible code to automate your estate. The second one is to operate that code. So effectively, how to ensure that everything continues to work as it should. And the third one is the consume. So if you're a user, you don't really care about the automation side. You just know that you want, let's say, a VM. And in that situation, you might be using automation without even knowing, because it might be hidden from you. You are opening a request of some kind, and then it just happens. But it's very important to focus on all 3 of those, because by focusing on all 3, you can really create good user experiences for all 3 of those personas. And if you start from the creating part, it's very important to understand that there are many different things that go into automation. Obviously, there is the runtime. Ansible has versions, as every other software, and it does continue to have new releases, which means that when you do automation, you have to create Ansible playbooks targeting a specific version of the runtime. And usually, if you upgrade the runtime, everything works. But still, since it's often very critical, the task that you're doing with the automation, it's very important to also test that that is effectively the case also for your specific playbook. Also, the playbook will have some dependencies on some collections probably. So the fact of having exactly the right version of the collection is very important. And those collections usually comes with dependencies. So they might depend on some specific libraries, they can depend on some specific command line applications that are running below it, or something like that. So to make sure that all of those components are exactly the right version, we have that idea of execution environments that we discussed earlier. And the way it works exactly is that you have that collection, libraries and core, plus a universal base image, which is like a very small container with all the tools that you usually would need into a Linux container. And all of this is packaged into an execution environment. Now, if you are creating execution environments, what you do is basically create a template, a manifest for that execution environment, describing which base image you want, which version of Ansible you want, which libraries you want, which collections you want, and then with the execution environment builder, you actually package that all those aspects into that image, and then you can push them into Private Automation Hub. Private Automation Hub is the component within Ansible Automation Platform to be like a registry for execution environments as well as collections. There is also an open source and free version, which is called Galaxy NG, but is exactly the same software. Once you have that execution environment, you can create your playbooks, and you can use Ansible Navigator to both navigate the various execution environments you have, the collection that you have, but also to run them so that basically you just put your playbook a certain execution environment and then you test on those. And if it passes today, it will always have the same result because that execution environment will not change. If your playbook does not change either, because you do expect the same result. So those are the playbook and the execution environments are the two base components of this automation. Now, those are not enough to give that enterprise automation that we have discussed since the beginning. So what you need is many more things. The way that we have packaged them is into what we call Ansible Automation Controller, which is part of AAP, but also the open source version is AWX. And what it does is give you API to trigger that runs or to inquire about previous runs, as well as workflows, so that once a certain playbook gets run and finished, either successfully or failure, it can then trigger other playbooks and maybe different playbooks if it was successful or failed. But obviously, it's also focused on managing credentials and logs because we want to have a software that makes life easier for all operation people as well. And if you look at like the whole architecture, what you would have is the users, and those are like automation users. Might be technical people or non-technical people, and they either go with the web UI or via API, maybe not directly, maybe there is a ServiceNow instance in between or any other system. And then they trigger automation jobs, either directly or in a more hidden way, if that's better for your users. There could be some approvals in the process, for instance, and or a self-service portal. And that control plane actually triggers executions of playbooks into that execution plane, which is made by execution environments. And as you can see, you can have many execution environments that could be co-located on one machine or many machines, and potentially many data centers as well, to ensure that you have the bandwidth of to automate many different tasks, to run many different automation tasks at the same time. And as a result, those will do the changes to all your environments that you have set to get the changes to. And as you can see, also this distinction help us to guarantee all that security that is required for those kind of operations. Now, I want to give you a couple of information about event-driven Ansible, because this is a different way of using Ansible from the previous image, and they can be done at the same time in the same organization, or you can pick just one of the two if that's better for you. And the idea of event-driven is basically that it changes a little bit the workflow. So in an event-driven workflow, we have an event that gets received, and this can be a lot of different kind of events. I think we have at the moment 20 or 30 officially supported kind of events. But then obviously you can write your own or find more from other community people or vendors. And once an event gets received, there is a decision made based on the event, so on the event structure or some specific fields that you have identified as valuable for this decision. And based on that decision, then an automation gets triggered. And all of this works across multiple vendors, multiple technologies, technology stacks, and so on. So just to give you an example, you could have an event that could be of any kind, because we don't really care too much about the source of the event as long as we can receive it, that says that a certain machine have a disk pressure issue. Now, maybe due to your rules, based on the specific machine that is, the specific disk, or maybe the time of the day, whatever means, whatever is sensible for your decision, the system decides that it makes sense to extend that disk. And what it will do is will trigger an Ansible playbook that extend that disk. So the way it works is basically with three building blocks. The first one is sources. So based on the source of the event, you will have a plugin of some kind. Consider that there are a few very generic plugins. So for instance, there is a webhook plugin where EDA provides a webhook to be called by any system, or a file plugin where the EDA will watch a file. If that file changes, then that's interpreted as the event, and many others. And then also there are some that are more specific to specific systems. And based on that, there are the rules, and also sources. If you have a custom source, you can also write your own plugin. Rules are divided in rule books, which basically are like playbooks, but for rules. And you will be able to write those, or potentially get some from other collections or other sources. And then actions. Actions are just the usual playbooks. So in the end, this means that you can trigger the usual playbooks that you would be using in your day-to-day life, but based on some kind of events in your environment. Now, this is EDA. EDA is part of AAP, as all the other components that we discussed, but it's also open source. The open source version is called EDA Server. The threaded AAP version is called simply EDA, but it is exactly the same one. Now, wrapping up, I think there are a few takeaway points that I would like you to take away. The first one is that automation is key to simplify and optimize IT operations, and this is no matter on how you do automation, as long as you do automation. But if you have an automation that comes out of a single platform, a single language, it will provide you way more value, because it will allow you to share that automation between the various silos. And also, an automation platform, to be defined as such, requires way more than just an automation tool. It requires all the other tools that allow your enterprise to actually base your operation on that tool, not simply use it in an opportunistic way. And also, Ansible does have that full ecosystem. It's probably not the only one that has that full ecosystem, but still Ansible has one. So with this, I thank you. There is the session form here. And if there are questions, we can open the floor.
Okay, thank you. Sorry, I couldn't get myself unmuted. If you would like to unmute yourselves and ask a question, you can do that. The floor is yours. Okay, so I'm not seeing anybody unmute themselves to ask a question. So I thought I heard a noise, maybe not.
No, it was me. Sorry.
Oh, it was you. Okay, so yeah, everybody, please feedback, and this session was 9N. You can use the QR code, and thank you for a very interesting presentation. Thank you.
Thank you.